Water is not the only molecular substance that shows dipole-dipole interaction. We've seen that the dipole effect is caused by one of the atoms in the bond having a greater pull on the shared electrons. This pull is sometimes called the electronegativity of an element. Hydrogen and most metal atoms have low electronegativity. Atoms of non-metals like bromine, chlorine, nitrogen, oxygen and fluorine have high electronegativity. So if two atoms with different electronegativities form a covalent bond, for instance hydrogen and nitrogen, we can predict that the resulting bond will be polar. Also that the atom with the stronger pull on the electrons will carry a small negative charge, and of course that the other one will carry a small positive charge. Fluorine is the most electronegative element of all, and it illustrates another prediction we can make. The bigger the difference between the electronegativities, the more the shared electrons will be drawn towards one end of the bond, and the stronger the dipole effect. Many important substances are formed by polar covalent bonds. We've already seen some of the effects that dipole-dipole interactions have on the properties of water. We see the same sort of thing in other substances. Sports drinks contain glucose. Glucose is a molecular substance with polar covalent bonds between the hydrogen and oxygen atoms. The dipole-dipole interactions created by these bonds cause the molecules to link together and form a crystal lattice. Table sugar has a similar crystal structure. We know that glucose and sucrose dissolve readily in water. Why does this happen? The sugar crystal is a lattice of polar molecules. Water is also made up of polar molecules loosely held together. The attraction between the water and sugar molecules is stronger than the attraction within the sucrose lattice, so when the two are mixed, the lattice breaks apart. Hydrochloric acid, with a polar covalent bond between hydrogen and chlorine atoms, also dissolves readily in water. So too does ammonia. In fact, it mixes so well that when 50 ml of ammonia is added to 50 ml of water, the total volume is not 100 ml but 98 ml. All the substance is still there, but the dipole-dipole interactions allow the mixture to pack together more closely than either substance can on its own. As a general rule, substances made up of polar molecules mix well together.